Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how you can use a graphing calculator to disprove an identity. Usually in trigonometry, you are asked to show algebraically that a trigonometric identity is in fact true. Sometimes you are asked to determine whether a trigonometric identity is true or not. And in order to prove that a trigonometric identity is not true, you can either find a value of the input for which the two sides would not be equal, or you could graph the two sides and show visually that they are clearly not the same. Unfortunately, for the first one, if you have to find a value for which they're not true, you might be able to find one by graphing, but you're going to have to show algebraically that it is in fact not the case, that they are equal. If you do just need to show that they're not true, and you can do that graphically, it's fairly easy to do graphically. Really what we want to do is we're going to graph both sides of the identity. So let's say we had to determine, is the trigonometric identity sine squared x minus cosine squared x equal to 1? Is that a true identity? Right, so graphically speaking, all I'm really interested in doing is, well, okay, let me graph both of those things. Right, sine squared x minus cosine squared of x, and I want to show or determine, is that always equal to 1? And so I'm just going to graph both things. Notice I'm doing it separately, and then I'm going to analyze the graph. Right, so there's the graph of sine squared minus cosine squared in blue, and the graph of y equals 1 is in red. And the idea here is, can you tell visually that there are points on one graph that are definitely not on the other graph? And so when you look at this, it's pretty obvious. If this were an identity and I graphed both sides, I should get the same graph, but I clearly do not. I clearly have two different graphs going on here, so sine squared x minus cosine squared x equals 1 is not an identity. Now, if the graphs overlap and it looks like maybe they're the same, that still doesn't prove it's an identity, because you might have numbers in the domain of one function that are not in the domain of the other, and so you'd have to quantify or qualify, is it a true identity or not? And if there's not equal domains, do you have to stipulate that it's an identity for all x for which both sides are defined? But you usually cannot prove an identity graphically because you can't see what's in the domain and what's not. But in these cases, you can definitely see that these are not the same, so you definitely can disprove most identities graphically.